related literature. Forensic science applies science principles, techniques, and methods to the investigation of crime. A lesser-known definition of the adjective forensic is anything argumentative or debatable. At first, this definition of forensic may seem to have no connection with the more popular crime-solving definition, but it does. Legal truth is sought through the use of adversarial systems, and decisions are made only after each side has been given an equal opportunity to argue all the issues at hand. When one of the issues being argued is a scientific analysis of an item of evidence, the debate that ensues over the science involved could be called forensic science. Other related definitions of forensics may include the use of science to aid in the resolution of legal matters and a scientific analysis for the purpose of judicial resolve. For example, saying that something was forensically determined suggests that the information was scientifically determined with the intent to be presented in a court of law. Recently, the term forensic has also been used to describe many scientific investigations, even if no crime is suspected. Often, these investigations are of historical significance and may or may not have legal consequences. For example, a forensic scientist may work on the detection of Renaissance art techniques or the identification of ancient human remains. Data analysis. Forensic science is the techniques and methods in the investigation of a crime. There are two forensic scientists, which is the forensic generalist and the forensic specialist. A forensic generalist is a forensic scientist familiar with the most areas of forensic science and capable of analyzing most items of physical evidence, but not necessarily considered an expert in every area. Forensic specialist is a forensic scientist that has become an expert in one of forensic science. To analyze physical evidence, forensic chemistry draws on chemistry principles and concepts. Investigating the physical and chemical properties of a substance is central to forensic chemistry. Physical properties are properties of a substance that can be described or displayed without requiring a chemical change. For example, sulfur is iron, is malleable. Cocaine is a white solid, while chemical properties are properties of a substance that can be described through a chemical change only. Although the exact manner in which the physical and chemical properties are analyzed for each substance differs, the analyses are all based on principle of the scientific method. Theory of forensic analysis includes question samples and known samples. Question sample is the sample being analyzed having an unknown identity. Known sample is the sample having a known identity of origin. Identification analysis is performed to determine the identity of a question sample. Presumptive analysis is a relatively quick and inexpensive type of forensic analysis, exploiting both chemical and physical properties of an item of evidence. Confirmatory analysis is a type of forensic analysis, exploiting unique chemical and physical properties of an item of evidence at the exclusion of all. Gas chromatograph mass spectrometer is an instrument used to first separate a mixture of compounds and subsequently measure the mass of each fragment of the separated compounds in the mass spectrometer. Classification is the linkage of a question sample and several known samples to a class with several possible individualization. Natural variation is the range of variation of class characteristic values within a substance of unknown origin. Sebum is a fat and dead cell containing secretion of sebaceous glands produced to protect and waterproof skin. Powder dusting is the use of fine powders dusting for fingerprints at a crime scene. Sublimation is the direct phase change from a solid to a gas. Microcrystalline test is a chemical analysis used for drug identification that produces representative solid crystals that can be seen under a microscope. Chromatography is a process of separating compounds using a stationary phase. Data presentation. Let's start with forensic science. What is forensic science? Forensic science is the application of science principles, techniques, and methods to the investigation of crime, which includes two scientists, which is the forensic generalist and forensic specialist. Forensic Forensic generalist is a forensic scientist familiar with most areas of forensic science and capable of analyzing most items of physical evidence, but not necessarily considered an expert in any area. Forensic specialist is a forensic scientist that has become an expert in one of forensic science. Second is the forensic chemistry. Investigating the physical and chemical property of a substance is central to forensic chemistry. This includes physical properties and chemical properties. Physical properties are properties of a substance that can be described or displayed without requiring a chemical change, while chemical properties are properties of a substance that can be described through a chemical change only. Scientific method. Although the exact manner in which the physical and chemical properties are analyzed for each substance, it differs. The analyses are all based on the principles of the scientific method. The scientific method begins with observations. Scientists attempt to organize observations and look for trends or patterns. When the scientists find what appears to be a relationship among the observations, they suggest a hypothesis that tentatively explains what is being observed. A plan is devised to test the hypothesis. Ultimately, the plan is carried out and further observations are made. If the new observations contradict to the original hypothesis, a new hypothesis is suggested and tested. However, if the new observations validate the original hypothesis, the scientists often choose to devise a subsequent plan to further validate the hypothesis. This cycle continues until the hypothesis has been sufficiently validated. Theory of forensic analysis has two samples, which is the question samples and known samples. Question samples is the sample being analyzed having an unknown identity. Known sample is the sample having a known identity of origin. Identification analysis is performed to determine the identity of a question. They contain two analyses, which is the presumptive and confirmatory. Presumptive analysis is a relatively quick and inexpensive type of forensic analysis, exploiting both chemical and physical properties of an item of evidence. Confirmatory analysis is a type of forensic analysis exploiting unique chemical and physical properties of an item of evidence at the exclusion of all. Comparative analysis. Comparative analysis is to link a question sample and a known sample to a common origin. The origin may be broad, resulting in a classification or exclusive, or it may be resulting in individualization. Individualization is the linkage of a question sample and several known samples to a single origin. Fingerprint development. Fingerprint development contains latent fingerprints. What is fingerprint development? Fingerprint development is the process by which hidden fingerprints can be seen, while latent fingerprints are hidden fingerprints created by the transfer of a minute amount of fingerprints residue to a surface. Fingerprint development has different kinds of process to develop evidence. Powder dusting. Powder dusting is the use of fine powders dusting for the fingerprints at a crime scene. Ninhydrin reaction. In years, biochemists have used Ninhydrin reaction for both qualitative and quantitative determination of amino acids. Silver nitrate reaction. When silver nitrate reacts with any soluble chloride salt, the insoluble salt silver chloride is produced. The reaction occurs almost immediately. The silver chloride produces a white solid that does not offer much contrast for a fingerprint development. However, as the silver chloride remains exposed to ultraviolet light, it decomposes, producing silver and chlorine gas. This produces a purple-black product that offers contrast to the evidence, or for the fingerprint development. Iodine fuming. Iodine is much the same way as solid carbon dioxide. It undergoes a phase transition from solid to gas, keeping the liquid phase, called sublimation. Superglue fuming. Items containing fingerprints to be developed are placed into a superglue fuming chamber. Liquid superglue is poured into a container and slowly heated within the chamber on a hot plate to produce superglue fumes. Phenolphthalein reaction. When used for fingerprint development of blood-containing fingerprints, the reactant molecule is converted to a colored product, resulting in a contrast fingerprint development. There are two kinds of analysis, which is the presumptive drug test, presumptive drug analysis, and soil analysis. Presumptive drug analysis contains color tests. Color tests are sometimes called spot tests. They are examples of presumptive drug tests used to probe question drug samples for their chemical properties. Soil analysis. Microscopic analysis. They use a microscope to observe a small portion of each sample. The stereoscopic microscope magnifies the tiny surface of that features the sample. Size distribution. Individual particles in soil samples vary widely in size. Investigators often find it difficult to determine the complete size distribution of a sample through a visual or microscopic analysis. Density comparison. Density is commonly used in forensic science when comparing items of evidence such as glass, plastic, wood, and soil. However, because soil is a complex mixture composed of many substances, each substance will have its own unique density. pH comparison. Soil pH is commonly determined, or soil acidity is commonly determined by forensic scientists during a soil comparison analysis after moistening the soil with a predetermined amount of water. Chromatography. What is chromatography? Chromatography is a process of separating compounds using a stationary phases, especially uses in presumptive drug analysis. Implications. Number 1. Examining human factors in fingerprint analysis. The accuracy of blood and print examination and the extent of human error in fingerprint analysis have also been the subject of recent studies in the field of science. One of the early recommendations from the expert is that crime labs develop a culture of openness, in which errors are identified, acknowledged, and used to improve analysis and reduce the error rate. Number 2. Helping the public. Improving the information available to all parties as a crime is investigated and prosecuted. For example, new forensic techniques to help identify human remains not only can assist authorities in apprehending the perpetrator, but also can provide some resolution to the victim's family. Scientists are developing more effective ways to identify bodies and pinpoint the time of death. Forensic anthropologists, for example, are mapping craniofacial features with 3D imaging to help determine the ancestry of individuals and using radiographs to more precisely estimate the age at death for juveniles. Conclusion. Chemistry is an integral part of forensic science. Forensic scientists must understand chemistry principles, concepts, and techniques. However, they must also be well versed in all legal matters relevant to the occupation, like the criminal justice system, state and federal laws, and chain of custody. Most importantly, forensic scientists must have spotless criminal records and only exercise the highest ethical standards upon completing an analysis. Forensic scientists must be able to present their findings in a court of law in a manner understandable to the general public. This requires an extensive understanding of analysis techniques in addition to the ability to speak publicly and articulate ideas clearly. Forensic scientists work neither for the defense nor for the prosecution. They simply serve as advocates of the truth under all circumstances. Insights. Forensic science and crime scene investigation isn't just cool, though it's a necessary part of bringing criminals to justice. Without forensic scientists, toxicologists, or osteologists, thousands of crimes would go unsolved every year. And of course, these after-the-fact mysteries are magnetic, and shows like CSI, Bones, and NCIS have the ratings to prove it. Forensic science is important because it aids in establishing the guilt or innocence of potential suspects. For me, forensic evidence is also useful for linking crimes, which establishes the patterns of crimes and also narrows the number of probable suspects. Forensic science is used most frequently with sex crimes and crimes related to drugs. Forensic toxicology establishes if an individual was intoxicated or high while driving after a deadly mishap or if somebody was poisoned to death. DNA proof retrieved from a victim's body can also ascertain who was accountable for physical or sexual violence. For me, weapon testing is yet another essential part of forensic science. Forensic experts utilize their expertise in ammunition to analyze the impact of a bullet, determine the number of shots fired, and pinpoint the exact position of a shooter. Lastly, by analyzing IP addresses and mining databases, computer forensics experts frequently help solve cyber crimes.